We're going to look at linear growth models, and I probably ought to put that word for you here. Linear growth models. And then next week we'll look at exponential growth models. So here's an example of something that has a linear growth model. You get a phone plan. The initial setup cost is $50 for the plan, and it is then $40 per month. Well, let's just sort of calculate the cost on a monthly basis. So starting with our very first cost, all right? So our initial cost of the phone. Well, we're going to pay that $50 setup fee, all right? Oops. Okay. Well, then we've got our first month cost. That's going to be, well, and let's think cumulative cost, how much we're paying over time. So our first month we'll pay the $50 setup fee, and then we're paying $40 for that first month. And then if we think about how much have we paid out at the end of 2 months, well, we're going to have that $50 setup fee, and then $40 for the first month, and the second month, of course, is going to cost us $40. And then our third month cost, well, we've got $50 and then $40 for the first month, $40 for the second month, and $40 for the third month. Okay, so let's just suppose that we're going on indefinitely with this idea. So let's get the nth month, no matter what the month is, right? So let's just think about this for a minute. The first month, we took the initial $50 and we added $140. The second month, we took the original $50 and we added $240s. The third month, we've spent the initial $50 and we've spent $340s. So our nth month, we can come up with a formula, is $50 plus 40 times n, okay? 40 times 3, 40 times 2, 40 times 1, no matter what month we're looking at. So if I asked, how much total cost do we have after 18 months? Well, then we could just plug in and do 50 plus 40 times 18, put our 18 in for our n, and we get $770 paid over time in 18 months. Okay, so this is called a linear model. And you might remember from algebra the formula y equals mx plus b, where the number being multiplied times x is the slope, and the number that's being added out to the side is the y-intercept. Now, we're not necessarily going to graph these linear models, but if we did, we would have a rising graph with slope 40 and y-intercept 50. And in fact, so if we wanted to graph this, we could use the equation y equals mx plus b, because we really have that right there. Our x is really an n right here, and we haven't written a y off to the left, but we could. But we could also do it this way. The initial cost is the cost at time 0. And so this corresponds to time 0, we pay $50. So if I go back here, now I've scaled my y-axis 10, 20, 30, 40, 50. So time 0, $50 would be right here. All right, and we'll let this be 1, 2, 3, 4, 5 on our x-axis, or we can think of it as the n-axis, since I used n back here instead of x for the nth month of cost. All right, so let's notice the first month will cost $90 total. So that really corresponds to 1 month, $90. And so when we plot that, 1 month, $90, 1 month, let's see, 50, 60, 70, 80, 90. That point would be right here. And I'm not sure if I've got enough tick marks to do another one. Let's see. We can see what the line is going to be like, but just so we can see that it is a line, let's do one more point. Second month cost, well, that's month 2, and if we added all that up, that would be $130. So second month, $130 to, let's see, 90, 100, 110. Yeah, it's just enough. It would put it right here. And of course, we do see those fall in a nice line. Now, I can't draw very well to make this nice and straight like it should be, but you get the idea of what that line is going to look like. And it's linear growth because our graph is a line when we graph these points. And even if we were putting even more points on this, if I had drawn my graph bigger, we would see that it would continue to be a line and go up in that linear fashion. So now a few things. You can see how we set these up, but some terminology might throw you off when you initially do your homework. We're going to refer to whatever the initial cost is as they'll be referring to it as P naught. So P with a little 0 at the bottom, and often we'll have a variable with a little 0 as its subscript to mean initial something. So just realize that in the future if you see it, that means initial something. Whereas this right here, our first month, we would say P with a 1 down as its subscript to indicate this is the first month cost, or P with a little 2 at the bottom to show the second month cost. Similarly, we might say, since we used N as the month, we might say N sub 0 for the initial month. Of course, we don't really have anything that associates with N sub 0 in the initial cost, but our first month we might say N sub 1, and so on, to indicate those amounts. Now realize it might not be P, they might call it something else. They might call it C sub 0, C sub 1. We can always change the name of our variable to indicate the cost at time 2. So realize that as you do your homework. Now, this definition is called recursive. And I'll write that up here. Because when we started this and we did our first month cost, we sort of used the first month cost to get the second month cost. And we used the third month of cost, or the second month cost, to get the third month of cost. So it's recursive. We keep going back to a previous version to add this up. When in truth, of course, we can come up with a nice algebraic equation. We don't have to do this recursive version that we did back here. We can just come up with a quicker way of finding an answer to a problem. Now, when we predict what something's going to be in the future, that is called extrapolation. So we're using a formula to predict what something will be in the future. And extrapolation can be somewhat dangerous because it could be that our cost changes in the future, and so this $770 for 18 months will be incorrect because our cost goes up somewhere in between 0 and 18 months. So an extrapolation is a formula based on everything remaining the same. Assuming everything remains the same, this is what our cost would be. We'll find out later as we talk about statistics later in the semester that extrapolation can be a very dangerous thing in a statistical model. Not necessarily in other models, like this one, for example, is a good model as long as the cost of our phone doesn't change. But some models will see that extrapolation can really be off.